Hello, today I'm going to talk more about inverse trig functions. Inverse trig functions are just like regular trig functions, only instead of plugging in an angle and outputting some number that is equal to the ratio of the sides, you're plugging in the ratio of the sides and you're outputting a number which is an angle. So I pretty much just put this right here. If you know the angle, do normal, sine, cosine, or tangent, because you're solving for a side length. If you know the sides, do inverse sine, cosine, or tangent, because you're solving for an angle. I use this symbol in my notes, the theta symbol for angle, and inverse is denoted with the power of -1. And so if you're using the TI calculator, under the control is the trig button, and that whole, when you press that trig button, that whole bottom row is all inverse trig functions. Other than that, it's pretty similar to what you already know about sine, cosine, tangent, so katoa. Sine's opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent is opposite over adjacent. That doesn't change. Okay, so the directions I say, you're looking for angle A. All right, so looking from angle A, 18 is the opposite side because it's not touching it. It is completely across from it. And 27 is across from the hypotenuse. Across from the right angle, so it's a hypotenuse. So the one that uses the opposite in the hypotenuse is sine. So I just write inverse sine now, or sine to the power of -1, and which is the universal symbol for inverse. So I just type that in, sine -1, 18 over 27, and it's going to output an angle of about 41.87 degrees. Okay? Looking at this one, angle A is here, so 20 is adjacent to it because it touches it. Adjacent means it's next to it or it's touching it. 20 runs into angle A. I got my hypotenuse over here with nothing by it, so it's really not relevant for this problem. And then 6 is completely opposite of A, so I'll put an opposite by it. So that means I'm using 6 and 20, my opposite and adjacent sides. So the one that uses opposite and adjacent is tangent. So I write inverse tangent, opposite 6 over adjacent 20, and that's going to be about 16.7 degrees for angle A. That's all there is to it. I'll do a couple more examples. I'm going to find both the missing angles. So really I can start with whichever one I want, and I'll do trig for both of them, but you don't have to, and I'll explain it in a second. So if I do trig for angle A, well, 3 is adjacent to A, and 15 is the hypotenuse. You might think, oh, they're both adjacent. Well, that's true, but remember, the hypotenuse is always across from the right angle, the longest side. So the one that uses adjacent hypotenuse is cosine. So I write inverse cosine of 3 over 15 equals about 78.46. I guess I should make squiggly equal signs for the approximation. And that was angle A. Okay? If I want to find out angle B, well then now 3 is opposite of B, and 15 is still a hypotenuse. So which one uses opposite in the hypotenuse? That would be sine. So I do inverse sine of 3 over 15 is about 11.54 degrees. So that was angle B. You could check your work. I could have just done one, well, let me not go too fast. You can check your work by seeing if they all add up to 180. So 78 plus 46.46 plus 11.54 plus 90. That all equals 180 degrees. You could have done 180 minus 78.46 and minus 90, or just simply 90 minus 78.46, and got an 11.54. But these notes are about trigonometry, so I'm going to do the trig anyway. So to find angle Q, I have 13 that's opposite of it, and I have 19 that's opposite of the right angle, so it's the hypotenuse. So that means I do inverse sine. And so I'm going to do inverse sine of opposite 13 over hypotenuse 19, and that'll give me about 43.17. Degrees. So this was a measure of angle Q. All right, now let's do P using trig. So I have the hypotenuse, still the hypotenuse, but now this is not the opposite, it's the adjacent side. So the adjacent, 13 is adjacent to angle P, so adjacent to hypotenuse uses inverse cosine. And so now inverse cosine A over H is 13 over 19. And that is about 46.83. Again, you could just type this in straight up into the calculator. As long as it's in degree mode, you'll get the right answer. That's Doc 7 too if you're using the TI Inspire. And that's measure of angle P. And again, you can check your work by seeing if they all add up to 180. Check. So you had that 90 degrees plus 43.17 plus 46.83, and they all in fact do equal 180. So that's good. I'm gonna go over the back in another video, solving a right triangle. Okay, so once I make that, I will link that to this video. But this is it for the inverse examples. All right, thanks. Bye.